Good day and welcome to the Math Salon again. This is Dr. Nemende. So we are going to look at differentiation, but a bit special in the sense that we will try to differentiate one variable not directly with respect to the other, as we normally do in the standard procedure for this circumstance here. So the question says, given that y is equal to cos inverse of alpha x on beta, and that beta is not equal to 0, so that this is still defined, show that dy dx is equal to minus alpha divided by the square root of beta squared minus alpha squared x squared. So we are given that y is equal to cos inverse of alpha x over beta. So in our normal procedure working, we will just say dy dx and then we try to differentiate that, but that is much more complex. We will take the easier way, which means I will try to say, I will take the cosine of both sides here. So that means my cosine of y is equal to the cosine of the cosine inverse of alpha x on beta. Of course, the cos and the cosine, they fall off. This is just equal to alpha x all over beta. You see now, instead of having y is equal to something as we normally do, so we just do dy dx, we will do an implicit form of differentiation. So what do? I differentiate this and indicate which variable I did with respect to. So this, I will try to differentiate with respect to y, then I get minus sine y. But I remind myself that I did that with respect to y. So I put the dy to say that is what happened. Here, alpha and beta are constant, so I can keep them outside. And I differentiate this x with respect to x. The derivative of x with respect to x is 1. So this is just times 1. And I remind myself I did that with respect to x. So if that is the case, then I'm left to try to fix this to get dy dx. I have dy hanging somewhere. I have the x the other side. So I try to take it into the salon and make it beautiful. So what do? I divide both sides by minus sine x. Then it comes this way. So I get dy is equal to alpha. I just put the minus there. The minus is coming from the sine y. Please, just for it to be beautiful. And my dx is there. And I take the dx. I divide it here. So I get dy dx is equal to minus alpha all over beta sine y. But of course, for this particular problem, we're asked to show something. So it's important to try to show that there is no y on my right hand side. So somehow I have to make this part containing y to disappear. But I know our famous trigonometric identity, the simplest one, the most important and loved one. That is saying my sine squared y plus cos squared y is equal to 1. So I can take this one this way. So my sine squared y is equal to 1 minus cos squared y. So that my sine y is equal to the square root of 1 minus cos squared y. Of course, I already saw here that my cos y was equal to alpha x on beta. So I can take this and just substitute here. So this is 1 minus cos y is alpha x on that. Alpha x all over beta, and the square is there. Because cos square x is the same like cos square y is the same as cos y all the squared. That's what we've just done here. And I do not forget my square root. And just to make it nice, it's not yet beautiful enough to leave the salon. So to do that, I have 1 minus alpha squared x squared all over beta squared. The lowest common multiple here is beta squared. So beta squared, you can say this is on 1, divided by 1 is beta squared times 1 is beta squared. So this is beta squared here minus alpha squared x squared, because beta squared divided by beta squared is 1. 1 times that gives me that. And remember, so I will take this now and just substitute here. So if we do that here, then this is minus alpha all over beta times the square root of beta squared minus alpha squared x squared on beta squared. The square root of a on b is the same as square root of a square root of b. So if I do that here, then this can go up square root there, and the square root below becomes just beta. Then you see that this would cancel that, and I'm left with minus alpha divided by the square root of beta squared minus alpha squared x squared. And that's what we're expected to show. This was a simple one. and straightforward, but the idea is that you get all the required tools before you get into your exams. I wish you luck again. Most importantly, remember, thumbs ups, share with your friends, those that don't have phones, they don't have computers, please share with them. Some have phones, they don't have data, share with them. When you share, you learn more. That is the key in mathematics as well. So in order to do that, remember to subscribe so that you get an alert once I upload new videos for you. And also, if you feel that there's something you still need to understand that I didn't make very clear, please leave a comment for me. Thank you.